Okay, for our first math lesson of 2017, we are talking about lesson 3.5. So that's module 3, lesson 5. And the learning goal you should have written down by now is at the end of today, you will be able to subtract fractions by drawing a model. So today we're going to be talking about subtracting fractions. Before the break, we talked about adding fractions by drawing a model. So today we're going to use the same strategy of drawing a picture, but instead of adding, we're going to be subtracting. You got it. Let's first talk about the problem of the day. When we have this problem, 3 boys minus 1 girl, it doesn't make any sense because the units are different. We have the units of boys and we have the units of girls. Can we do that?
No.
No. If I had 3 boys minus 1 boy, could we do that?
Yeah.
Yeah, the answer would be 2 boys. We can do that because then our units are the same. How is this related to fractions? Well, when we were looking at addition, we knew that when you have the same units, 1/4 plus 2/4, we can add that, can't we? If I have 1/4 and I add 2 more fourths, how many fourths do I have?
3/4.
3/4. My units were the same. We were all talking about fourths. But if I have, let's say, 1/4 plus 1/2, can we do that?
No.
Not yet, because our units are different. We would have to convert or change the units so that they would be the same. It's the same with subtraction and when we're subtracting fractions. Okay, so let's take a look at an example. Let's write this down in our notebooks. We have 1/2 minus 1/3. Are we ready to start subtracting? Why not, Ella?
Because the units are the same.
Because the units are not the same. What are our units for the first number, 1/2? Our units are halves, right? What are our units for the third or the next number? Thirds. We have halves and thirds. Are those the same? No. So before we're ready, we need to convert them to be the same units. Okay? So go ahead and draw your model. This is 1/2. And this is 1/3. Would you agree? Okay. Now remember, when we draw models, we can convert them to be the same units by imagining what it would be like if we overlapped those two rectangles. So if I overlapped my halves with my thirds like that, how many total rectangles do I have? Or how many total sections do I have here? 6. So we're going to make each of these have 6 rectangles inside, or 6 sections. I can do that to this one by adding 2 lines this way. And I could do it to this one by adding 1 line down. Now, do each of these rectangles have 6 sections in the middle?
Yes.
So by looking at this picture, we can see that 1/2 is equivalent to how many 6? 3 6. Okay, so draw and write this. And by looking at this picture, we can see that 1/3 is equivalent to how many 6? 2 6. Now, are our units the same? Yeah, right? So now, if I have 3 6 minus 2 6, I have 3 6 right here. Wait, I'm going to do it down here too. 3 6 and 2 6. There we go. If I have 3 of these 6, 1, 2, and 3, and I take away 2 of them, how many 6 do I have left? 1 6. So therefore, 3 6 minus 2 6 equals 1 6. Okay. Go ahead and take a minute to catch up your notes so that they look like what's up here. Now this problem's a little bit different. How is this problem 4/5 minus 2/3 different than the 3 problems we just did? Take a look and compare. What's the difference between this problem, 4/5 minus 2/3, compared to when we did 1/2 minus 2/7, or when we did 1/2 minus 1/3, or things like that? How is this problem different? Jack? Right, in the problems we did before, what numbers was mostly in the numerator? 1. Right? If you look back at the problems we did before, 1 was always in the numerator. In this problem, do we have 1 in the numerator?
No.
No, we have a 4 in the numerator and a 2 in the numerator. Does that make this problem harder?
No.
Nope, it just makes it different. Okay? So, think about it first. If we draw a rectangle and we divide it into 5 sections, 1, 2, 3, 4, 5. And then we have another rectangle that we're going to divide into how many sections? Into how many sections total? 3. If I were to overlap these, how many sections would I have altogether? 15, so that's our goal, okay? Let's start by drawing 4/5. I can do that by drawing a rectangle and dividing it into 5 sections. There we go. Ella, how many of those sections do I need to color in?
4.
4, you got it. 1, 2, 3, 4. Then I'll draw my next hole, or my next rectangle, and divide it into how many total sections, Sophia? 3, because I'm trying to model 2/3, right? And how many of those sections do I need to color in? 2. And of course, we're going to label these 4/5 and 2/3. Now, if I aim for those 15 total squares, I can do that by drawing those 2 lines there and dividing it this one like so. Now, as we mentioned, how many total squares or how many total sections do we have in each model? 15. Does that mean 15 should be my numerator or denominator? Yeah. So 4/5 is equivalent to how many 15ths? Well, I can count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then 2/3 is equivalent to how many 15ths? Let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, do I have the same denominator or the same units? Yeah, I have 15ths. So if I have 12 15ths and I'm going to take away 10 of those 15ths, what's left? 2 15ths. Before I write my final answer, I need to check. Is that fraction 2 15ths in simplest form? Yeah, that means that will be my final answer. 4/5 minus 2/3 equals 2 15ths.